Greetings, YouTube. My name is Ed Gomez, and I'm a senior .NET developer and lead architect with over 30 years' experience in software development. I've worked at many major financial institutions, and I've done this for a while. Everything I'm about to teach you comes from real-life experiences. I'll take the theories and concepts and show you their practicality in business uses. If you like this video, please remember to like and subscribe and hit the notification icon to be notified of new content. In our previous video, I discussed the single responsibility principle. Now let's tackle the O of the S.O.L.I.D paradigm, which is the open-close principle. So what is the open-close principle? An object should be open for extension, but closed for modification. How can you possibly do that? With the same breath, we're saying extend it, but don't make any changes to it. Logically, that makes no sense. But we'll make sense of it shortly. There are two design patterns in particular which lend themselves well to the open-close principle. One is a template pattern, and the other is a strategy pattern. Many of you might already be working with a template pattern and not even know it. If you inherit from a base class with virtual methods, then that's a template pattern. For the open-close principle, we'll be using a banking example. In our scenario, our banks use the same logic for deposits. However, withdrawals are bank-specific. We want to create an object that is open for extension, but closed for modification. By creating a base class with virtual methods, there's no need to change it. We merely override the method that is different for a bank, which in our case are the withdrawals. If you don't override the withdrawal method, you're given a default implementation, which is to reduce the available balance by the withdrawal amount. Okay, here's the solution, and I've broken down the template pattern and the strategy pattern. Here's the base class, or the template class, which we'll be inheriting from. You'll see that it inherits from an interface called iBanking process. And notice, as mentioned in the comments, there's one virtual method, and that's for withdrawal, because we said all the deposits in our case are all the same, except that the withdrawals are different. Okay, so we have an example here of commercial banking, inherits from banking. Remember, if you don't supply something, it will allow it. So we already have a banking template, which inherits from iBanking, all right? Now, CommBank allows for an overdraft limit of $1,000. Not really, this is basically fictitious. As you can see, internally, it has a variable called allow credit, and it's hard-coded for 1,000, all right? So, we inherit from banking class and merely override the withdrawal method as indicated. Deposit logic is handled by the base class, so we don't need to override that one. We have extended the functionality without modifying the base class. Now let's discuss how we do this using the strategy. Let's look at what I call an ugly if. I've got this ugly process there. Every time a new bank comes in, I'll need to add this to the ugly process method. Not only that, but I also have to create another bank-specific withdrawal method. Here's one from Fidelity. Again, this is fictitious. Right? You see it has a different one, different method altogether. And you see Fidelity, he has a reserve amount of $200. The banker must keep a $200 balance. Okay, let's go to the daily process over here. Let me see if I can find, yeah, it's here. Right, now the ugly if gets even uglier. This means another build and another release, which could result in a regression failure by you inadvertently adding a bug to existing code. The less you touch your code and the more automated tests you have, the better. This violates the open-close principle, whose purpose is to avoid introducing bugs to an existing code base and which facilitates code maintenance using a strategy pattern. Very little code, right? That's because all bank-specific code is now in its own strategy. In this example, which is common with the strategy pattern, we'll also be soliciting the assistance of a factory. We've created an iBanking process interface which all banks must inherit from. You'll notice the interface has 4 methods: withdrawal, balance, deposit, and process. Here's the entire solution. Fed Fidelity is different than commercial bank in that it has a reserve amount of $200, meaning that the customer must maintain a $200 balance at all times. Now, each of these strategies can inherit from banking and iBanking process and override the withdrawal. That's an example of the template pattern. But for this strategy pattern example, all bank-related code is self-contained in its own DLL. Here's an example of favoring composition over inheritance. I compose a DLL for each banking strategy, and I have no dependency on the banking class. Quite often, you'll find yourself using more than one design pattern. We're going to incorporate a factory pattern that our client calls to get the correct strategy for a specific bank. I have a dictionary with all the iBanking process banks and a default also known as a null object. This will be discussed shortly. The good process no longer needs to be updated and it is therefore closed for modification. The factory is the only one that will require updates, but we can create a brand new strategy and merely load it into a dictionary. With an IOC, which we'll discuss later, we can go one step further and use reflection to load all iBanking processes objects into a specific directory, and then use reflection at runtime to load all bank strategies at runtime. And this too will be totally open close because you never need to update it. Just add another bank because so long as your bank is inheriting from the iBank process, it will automatically get loaded at runtime by reflection. This means deployment is facilitated merely by dropping a DLL in a predefined directory. Microsoft Prism 5.0 IOC has a facility of directory catalog for loading DLLs based on a directory structure at runtime. For more information, you can look at the MS Prism PDF. The good process asks the banking factory for a particular bank, which the factory fetches and returns. It then merely calls the bank's process method, and it passes it a bank transaction for processing. But what happens when a bank is passed with no banking strategy? If the factory doesn't find an associated bank strategy, it merely passes back a null object or default object, if you will. Because the factory returns a default implementation, it's therefore open-close, as no modification to this code is necessary. So this concludes the open-close principle. I hope I've shown you how valuable a concept this can be for creating robust, maintainable code. I also just didn't describe this principle. I gave you an example of how to use it and hopefully encourage you to add this to your skill set. I also included 3 design patterns, and I've shown you not only how they all relate to the open-close principle, but how they relate to one another. You saw me use a factory together with a strategy pattern to facilitate the open-close principle. And I also mentioned IOC, which will be discussed on a later topic. The links from my book titled Software Development Accelerated Essentials, What You Didn't Know You Needed to Know, are available below. Just take a look at the table of contents to see the wide range of topics I discuss. The book is broken down into 2 components: building the company, which is how to develop maintainable code, and running the company, which includes production releases, data warehousing, job scheduling, and so much more. So whether you're a developer or an IT manager, there's lots of information available for you in a one-stop shop resource. Please consider leaving me a review at those links, and thanks in advance.